Hey there. The the equation you set up in your post was totally right. Um, Let me run through 21, and then I'm going to try to convince you that 21, 22, and 23 are all the same problem with different words. And kind of once you figure out the trick to getting them set up, you just kind of keep doing that over and over. So let's do 21 first. So we got 650 tickets are sold for a game for that much money. Adult tickets are 250, kid tickets are a buck. And how many of each kind of ticket were sold? So when we do these, and not every problem works out this way, but these three do. There's like an easy equation and then a harder equation. I think of the harder one as kind of being scaled. So the easy equation, and then the other thing in there is there's a good thing to do is to look for totals. So right here, this is saying there's a total of 650 tickets for a total of that much money. And what that tells you is you're going to write one equation for the number of tickets and one equation for the amount of money. So these are going to be kind of like the equal side of the equation. So if 650 tickets were sold, and we had adults plus children, that has to make 650. And that's the easy equation. And then you actually had the hard equation already. So 250, and I'm going to call that 2.5 just to not have that zero there. But that's $2.50 for adults plus a buck for kids. So that would just be one C. So I'll just write that as C. So $2.50 for each of these tickets plus $1 for that each of these tickets is going to make the $1,212.50. And then when I go to solve this, like this is what I do every single time. When I look at these two equations, whichever one is the easy one, I manipulate that one. So out of these two, this is the easy one. And then this is a 1, so all I got to do is multiply this one by -1. So I'll just do that right down here. So I'm going to go, let me show that. So it's like I'm doing this. I'll toss that right below here. So that would give me -a minus c equals -650. And I always, when I go to solve, if I have two numbers here that I'm working with, I always make the smaller one negative. And the reason is that's going to keep the rest of the stuff positive. I could have multiplied this by -250 as well, but then I would have two more negative signs that I could potentially lose as I go through the problem. So I always make the smaller of these two numbers negative. And then from there, let's see, where to put the calculator? Here we go. So that would be 1.5. The C's drop out, that was the plan. And then we're going to have 12.5 minus 650. That gets us 562.5. And then we could just divide the 1.5 on both sides, and that gives us the number of adults. So divided by 1.5, and we get 375. And then if we go back to I always go back to the easy equation because I don't like to do more math than I have to. So 375 plus C makes 650. In other words, if there's 375 adult tickets, so if I just do the 650, 650 minus 375, and we get 275. So that would be the children's tickets. So just to recap that, we're going to have an easy equation and probably a harder equation that's scaled with something. So in this case, it was scaled with the cost of the tickets. In the next one, it will be the percentages. And then work on the easy equation and take whichever one of these two numbers is smaller, do that one as your negative. Again, you get easier signs. It's otherwise just a minus and a minus when you do it. And it's just kind of one more thing to make a little error on. And then once you get that first one, go back to the easy equation and then get your second answer. So that's basically the strategy for all three of these. So let's take a quick look. I won't run all the way through it, but let me set up 22 and 23 just to try to show you that these are all the exact same problem. So for 22, we have Mr. Jones has $19,000. He invests part at 8%, part at 10%. If he earns $1,700 in interest after 1 year, how much did he invest at each rate? So let me clear this. And if you look, so the first thing I do is I look for totals. So Mr. Jones has $19,000. Cool. So there's one of my totals. So he's going to have some, I'm going to count this one, X and Y. So he has some amount in account X plus some amount in account Y. And that's going to make $19,000. So that's the easy equation. And then the harder one, that's the scaled one. And that's going to include everything else here. So he invests some at 8 and some at 10% to make this much interest. So this is the equation for the total amount, and then this one's the equation for the interest that's paid. So we know he gets 8% on one of these, so it goes 0.08 times x, and however much is in there, if I went 8% of it, then that would give me that amount of interest. And then he's got 10% in the other one, so I'll call that 0.10 y, so that would be 10% of how much is in this. So this is the interest payment from that account plus the interest payment from that account makes the total interest. So that's where once you kind of figure out what your totals are, then you can, that helps you get the rest of the equation set up. To solve this, what I would do, and I won't go all the way through it, but again, 0.08 and 0.10, 0.08 is the smaller number, and so I would go negative 0.08, negative 0.08 on both sides, and then that will keep my numbers positive when I add those together, and then you'll get, when you do that, you'll get y, and you just plug it right out. So say y is 10 grand, you plug it in here, and then the x has to be 9,000. And I'm just making those numbers up, but go back to that easy equation because it's easier. And then 23, let me just, let's see, clear. Mary Jo spends $1,260 to buy stocks in 2 companies. She pays $24 for one kind and $27 for the other. She ends up with 50 shares. How many shares did she buy at each price? So here we got kind of 2 totals again. We have the total amount of money she spent and the total number of shares she ended up with. So the shares is easier because that's what we're trying to figure out is how many shares she bought. So I'm going to just say she has, oops, let me change that to black. She has some number of shares of stock X and some number of shares of stock Y, and together that's going to make 50 shares. And then we know she paid 24 for one kind, so I'm going to call that 24X. She paid 27 for the other kind, and that's going to be 27Y. Doesn't matter which one you call which. And then, how much did she spend? $1,260. So 24 times however many of those she got, plus $27, however much that she got, should be the total money. And there's the $1,260. So again, we kind of figure out, like, at least on these ones, there's an easy equation, and then this one that's scaled with kind of all the other stuff in the problem, and then identifying those totals. That's really kind of the key to deciphering those. And then to solve, like, you can do this a lot of ways, but to me the easiest thing is to just take the smaller of those 2 numbers and make it negative, and then multiply that out, add them together, and those x's will drop out, and you'll have y, and then you come right back there and get your x from that simple equation again. So really, hopefully that kind of helps you see that they're all really kind of the same, those 3 are all the same setup. And I'm solving them all the exact same way, and it's just sort of deciphering how to get that easy equation and then the scaled one out of there. Hopefully that helps out. Holler if you have more questions.